Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. Troubleshooting networks effectively and efficiently is really an art form. Luckily, it gets easier over time, and the better that you can follow an effective strategy. We're going to start out by covering some hardware tools that you might use, and then we'll move on to software tools. Hardware tools are physical tools that help you testing. Let's talk about some of the options that you need to know about. Cable issues usually are only a problem when they first get installed or when changes get made. After that, when the network is up and running, cables don't usually fail, but if they do, the link will be completely down instead of slowing the speed down. Some common cable problems include an open circuit where the wires in the cable don't connect from one end to the other. The second problem is that a cable might have a short where one or more wires in the cable connect to another wire in the cable. Cables might also have a wire map problem where one or more of the wires in the cable don't connect to the proper location on the jack or the plug. This is the result of improperly crimping a cable. Cables might be experiencing crosstalk where electrical interference is occurring. Broken cables might pick up noise or other signals from faulty hardware or poorly crimped jacks. Or broken cables might have impedance mismatch from an issue with electrical resistance in that cable. Let's talk about some of the tools related to cable testing. Cable testers will tell you if you have a continuity problem or if a wire map isn't correct. Time domain reflectometers, or TDRs, will tell you where the break is on the copper cable. Optical time domain reflectometers, or OTDRs, will tell you where the break is when dealing with fiber optics. Certifiers can make sure that a cable can handle the capacity that it's rated for. These are useful if you're having slowdowns in your network. Fiber light meters allow you to measure the amount of light that reaches a detector on the opposite end of the cable to see if there's any issues. You might also hear these called power meters or optical power meters. All this technology needs proper power voltage and temperatures to operate. Voltage quality recorders and temperature monitors allow you to monitor rooms to look for issues with either electricity, heat, or cooling. If you ever find yourself needing to create a cable that can connect to a system, you'll need a few special tools. The first tool is a cable stripper, which allows you to strip away rubber coating on wires. Cable crimpers allow you to connect the strip wired section with a connector that you can use. Snips are another tool that can help you cut through metal-like wires. If you were going to connect the cable to a patch panel in a data center, you could use a punch-down tool to put unshielded twisted pair wires into 66 and 110 blocks. Multimeters let you test both AC and DC voltage resistance and continuity. I also wouldn't recommend going with the cheapest multimeter or really tools in general because the good stuff works better and won't break on you. Tone generators connect to one end of a cable and tone probes connect to the other to scan wires and ports to see which connects. For the Network Plus, there's several tools that you need to be aware of, and they basically can be categorized as the tools that are built into systems and tools from third parties that you'll need to install. Make sure that you have an understanding of what these tools do and what their outputs look like. As a network technician, you need to be familiar with and comfortable with the command line interface or the CLI of systems so that you can troubleshoot and configure devices. The CLI is a shell, and simply it's a way to interact with the operating system, and terminal emulator programs allow you to access various CLI shells. On Windows, you might have heard of the command prompt window, and on Linux or Mac OS, the terminal window or application, which are all built into the respective operating systems. There are also third-party options that come with additional features, but they need to be installed, like PuTTY and my personal favorite, Secure CRT. The hostname tool or command will print out the hostname of the current system to the shell. I know its functionality isn't overly impressive, but you'd be surprised how often you might need that information. The traceroute utility lets you trace the routers between 2 points. This can be helpful to troubleshoot connectivity problems with remote systems. On Windows systems, the command you'll use is traceRT, and Windows uses ICMP packets. On Linux or Unix systems, you'll use the command traceroute. Now, these systems use UDP datagrams by default, but you can also use TCP segments. I want you to keep in mind the difference between the data types, because if a firewall or router is blocking that type of traffic, you might have better luck on the other operating system. Also, if you want to force IPv6, then you just have to add the -6 flag, or on Mac OS and Linux, they have an IPv6 specific version called traceroute 6. Have you ever wanted to know what the IP address is of your system? Well, ipconfig for Windows, ifconfig for Mac OS and Unix, and IP for Linux can tell you a lot of information related to IP settings on your system. ipconfig/all is especially useful if you want DNS server and MAC address information on a Windows system. ARP, or the Address Resolution Protocol, is what we use to resolve IP addresses to MAC addresses. The ARP tool is a command line tool that lets you view the information of mapped MAC addresses and IP addresses. In the command line, ARP-A is a useful command that you should definitely memorize. Ping is a utility that uses ICMP packets or Internet Message Control Protocol packets to query an IP address or named resource. Ping is most commonly identified as a troubleshooting tool to check connectivity with another resource or system. One thing to keep in mind is that since ping uses ICMP packets, a system, firewall, or router that's configured to block ICMP packets won't give you an accurate result. Using ping by default, we check IPv4 connectivity, but if you use the -6 flag, then you can force it to use IPv6. ARP ping is an alternative tool to ping on Unix and Unix-like systems that use ARP frames instead of ICMP packets. The downside is that ARP packets don't pass through routers onto different networks, just within the broadcast domain. Microsoft also has a tool called PathPing that combines the ping and traceroute functionality with some additional features. Keep in mind that PathPing will stop when it hits a site that doesn't respond. DNS is a major part of the networks that we use, and it maps IP addresses to names. Two tools that can help troubleshoot DNS are NSLookup for nearly all operating systems, and it's the default on Windows systems, and Dig for Mac OS, Unix, and Linux systems. You can see that I've included a sample command to look for mail exchange servers or mail servers. I would take a few minutes to look through both these tools to see which type of flags or options that you can use, but like a lot of things on the Network Plus, you aren't going to have to be an expert. My traceroute, or MTR, combines traceroute and ping. MTR is on Unix and Linux systems, but you can also find a Windows version called WinMTR, or you can run MTR by using the Windows subsystem for Linux, WSL, in Windows 10 and 11. Just like PathPing, MTR runs a traceroute along a path, but it won't stop if it reaches a site that doesn't respond, and instead it'll keep going and try to reach the end. That makes MTR a more precise tool. What if you want to see a routing table on a local system? The route command will display the routing table, and you can edit it if you want. Some of the common commands that you should know include route print, but you can also use netstat-r. If you need to see the current state of all running IP processes on a system, you can use the netstat utility. You can see information like what sessions are active and additional statistics on ports or protocols. If you just use the netstat command by itself, it's going to show you current sessions. If you use netstat-r, like we already mentioned, it'll show the routing table. On Linux systems, you have another option, and that's to use the SS utility, which is faster and more powerful than netstat. Packet sniffers are tools that allow you to capture network packets, which are called a packet capture. Typically, packet sniffers are bundled with protocol analyzers, which allow you to make sense of the packets and see what kind of traffic or activity is taking place on the network. Wireshark is the most common packet sniffer and protocol analyzer with a graphical user interface, or GUI, that you'll come across. TCP-dump is another packet sniffer option that you can use from the command line, and then you can review the capture files later in a program like Wireshark. If you ever want to probe a system to see which ports are open, you'll want to use a port scanner. Knowing this type of information can help identify ports that are in use or ports that you can potentially close to limit the attack surface. Nmap, Angry IP Scanner, and Nessus are three common options that you can use to scan ports. Bandwidth speed testers enable you to measure the data flow in a network. Sometimes these are also called throughput testers. If you've ever heard or used one of the many speed testing website options out there, that's what this is. Looking Glass sites are remote servers that you can access with a web browser to perform various diagnostic testing like ping, traceroute, and others. A quick search on Google will show you plenty of Looking Glass site options. Let's talk about some important rules and a methodology that you can follow for troubleshooting. Troubleshooting in itself can be a challenging thing to do, even for just the simplest piece of technology. There are a few things that I want you to keep in mind whenever you're troubleshooting. The first thing that I want you to keep in mind is you want to avoid making any problem any bigger than it is. Even though this might unintentionally happen, you want to avoid it if you can and be very cautious about anything that will delete or destroy data. The second thing that you need to do is always make backups. Remember how I said don't destroy or delete data? Data is extremely valuable for a business, and if it's gone forever. Even though troubleshooting can be challenging, if you follow a methodology or a process, things can at least be manageable and organized, which usually leads to better results. The first thing you have to do is identify the problem. Ideally, you want to identify the root problem and not just a problem, because otherwise you might still have a larger problem on your hands. It's not uncommon for something small to get reported, like a single computer doesn't have an internet connection, when in fact, the entire west side of the building doesn't have an internet connection. You get the idea. Collect information, talk to users, identify any symptoms, see if anything's changed like settings or new systems were introduced. Duplicate the problem if you can, and approach multiple problems individually instead of collectively. Second, you need to create a theory about the probable or likely cause of the problem. This step can get easier with more experience and knowledge, but knowing how things work will dramatically improve your ability to create accurate theories. Think about obvious things and follow the path up or down the OSI model. Third, test your theory to determine the cause. Now, testing your theory doesn't mean to take all the steps that it requires, but find small tests to help confirm or deny your theory. If you can confirm that your theory is true, then you can determine resolution steps. Otherwise, you need to generate a new theory or escalate the issue. Fourth, create a plan of action to fix the problem and identify potential effects. What will happen if you take certain steps to fix the issue? You want to carefully think this process out so that you don't make the problem any bigger. Fifth, start implementing the solution or the fix and escalate it if necessary. Follow best practices if there are any, and please, please, please document anything that you do, including if you tried something that didn't work and had to change things. Sixth, test the system for full functionality, and if you need to implement any type of preventative measures, then do so. Make sure that things are back to working condition and that the issue is resolved. If the issue is resolved, but then there's a new issue, finish all the documentation and steps in the process and then start again. Seventh and finally, document your findings, the actions that you took, any outcomes that resulted, and any lessons that you learned. Documentation is crucial within an organization, and it becomes more true the larger the organization. What if you implemented a fix for a problem, and then 6 weeks from now, another related issue pops up? You aren't going to remember all the details, and they could help you with the new issue. It's also true that the fix that you implemented could end up having a better solution that either didn't exist at that time, or maybe you didn't even know or think about it originally. In this section, we're going to talk about some of the common issues that you might have to troubleshoot in your career. Since networks are the key to systems communicating and accessing the internet, it's only fitting that we talk about how to troubleshoot key network issues that you might see. It's not uncommon for configurations on devices to get changed or modified throughout the course of the day, week, month, or year. Hopefully changes like this are documented because they should be, and that can provide you with an idea of what's going on. If there's no documentation, it's not a bad idea to start talking with whoever has access to the devices. Cisco devices will use a show run or show config command, and those will be useful to check the settings. Interfaces like the Ethernet network interface allow networks and devices to connect to each other. If an interface is shut down or not in an operational state, this will create issues. On Cisco devices, the show interface command can be used to check their status. Routing tables on devices like routers and switches are important because they tell traffic where to go. When routing tables don't have the correct routes, they might not forward traffic correctly, if at all. The show IP route command on Cisco devices allows you to check the routing table. If a port on your switch is in the wrong VLAN, any device connected to it might not be able to send traffic or interact in the network like it needs to. This is especially true if you have your network segmented or separated like it should be. Network monitoring systems, or NMSs, are great for keeping benchmarks on your network performance and to identify patterns of network traffic. If your network traffic spikes suddenly and performance slows down, then you have a decent idea of the problem. Troubleshooting doesn't always involve a remote system, and sometimes you actually need to be physically at the system to fix things. These are some of the hands-on examples that you might see in real life. Power failures, where the system might need an uninterruptible power supply as a battery backup. Hardware failures aren't frequent, but they can happen too. If the NIC card goes out, you might need to replace it. Usually they have an LED light on them to show activity, but you can also try a different cable too. Hot swappable devices like small form factor pluggables on your switches might go bad. EMI, or electromagnetic interference, isn't something that you can detect from a remote location. You have to be in that building to find out. IP settings like the correct subnet mask or default gateway might make a device unreachable, and you'll be required to log in locally on that system. Wired and wireless network conflicts might happen if a system's trying to use both wired and wireless networks at the same time, which results in no network connection. You'd again have to log in locally and disable one of the adapters or change the priority of which one's used in the network settings. Sometimes configurations can stop you from accessing resources. These problems are called nearby problems. Client misconfigurations typically happen with a single device when there are manual configurations that are set. That's because DHCP will take out large chunks of devices, but if a system doesn't have the right IP address, subnet mask, DNS servers, or default gateway, then you'll need to correct it or change it to DHCP. Server misconfigurations are more likely to cause issues on a network. That's because services like DHCP or DNS are distributed from here. VLAN misconfigurations can happen on switches when the correct ports aren't added to a VLAN or if a VLAN trunk isn't configured with the correct VLANs. Systems might not have the correct amount of access if this happens. Link aggregation problems happen on both sides of the connection when they aren't configured to allow either the LACP or the PAGP protocols to work. Typically, you'll enable this to increase the throughput by combining ports into one channel, so you won't get the speed benefit if this isn't correctly configured. Broadcast storms are caused by looping broadcast messages, and they make the network slow down to an unusable level. Switch loops are similar to broadcast storms, but the spanning tree protocol, STP, usually helps prevent this. Multicast flooding also generates a lot of multicast messages that slow the network down. If you have devices that are sending out a lot of multicast messages, make sure they're in a separate VLAN or that you can use IGMP snooping on your switches. Time issues aren't that common, but if clocks aren't synced up, then you can have issues with certain services. Collisions aren't common either on today's networks unless you have a device specifically set to use a specific bandwidth or duplex setting that's causing a duplexing issue. Low optical link budget can happen if you try to exceed fiber cable capacities or links. This isn't probably something that you'll see unless you try to do it yourself for fiber installation. Licensed feature issues can cause problems if you're trying to do something that your equipment license doesn't cover. Typically, enterprise gear licenses are much more specific in their capabilities, so you need the proper license or subscription for many features. Distance problems are the kind of problems that can impact your ability to reach distant locations either over a WAN or the internet. Router problems like configuration issues or access control list rules can prevent traffic from getting to its destination. Of course, you can always have power issues on routers too. The traceroute tool works great to see where traffic is failing to pass so that you can investigate a specific router. Some networks will use asymmetric routing, meaning that packets take a different return route, and this can cause issues for NAT devices and security devices that are looking for specific return traffic. Routing loops can happen, but they're usually a result of a misconfiguration. Fortunately, the TTL, or the time to live metric, decrements every time a packet goes through a router, so eventually it's going to time out. Appliance problems can happen with things like NAT interface misconfigurations or just using the wrong interface. Certificate issues can be of concern, and they'll give you certificate errors or warnings on your website. Company security policies can limit or restrict traffic on networks. For example, you might have a throttling policy or quality of service policy to give priority to certain traffic. You might also block certain traffic. Network performance issues can impact the productivity of users in your entire organization. As the organization grows, you have to monitor the performance against the network performance baselines, and sometimes you just need a bigger network pipe with higher bandwidth capabilities. Something that I want you to keep in mind is that you'll never know everything. Especially as a newer professional, there's going to be things that you don't know, and over time you'll get better at identifying when to ask for help or to escalate. Don't feel like you have to keep trying without making progress before you ask for help for things that are outside of your abilities. I'd also recommend to continue learning as much as possible from certifications, technology resources, and more experienced staff throughout your career. Someday you'll be the person who everybody escalates issues to because you have a large amount of knowledge and experience. It's a cycle of life.